Perception is analyzing sensing data that the robot gets and outputting useful information for downstream tasks.
Generalized robots are not quite possible without actively perceiving your environment and understanding it.
Consider this image. You probably almost instantly recognized it as a frozen cube of broccoli without even thinking about it. Most people probably take for granted how quickly and how accurately their eyes detect what is in front of them, even in new scenarios. But when designing perception systems for robots, it becomes apparent just how efficient our eyes really are, and the sophisticated connection they have to our brain.
The perception work that we're doing at Agility is fairly unique. We're developing algorithms that will go on a physical platform, go out into the world and do actual work.
Digit is a mobile platform, and it's real-time environment interaction. So with static cameras, you can go and play back images. They have no motion blur. You can really kind of control your environment a lot. But with Digit moving around, the effects of how you detect the first thing also subsequently affects everything after that.
If we're doing something like terrain mapping, we want to make sure that that's accurate so the robot doesn't trip on obstacles or clutter in the environment. We can also think about things like object detection or obstacle detection. We don't want Digit out there running into objects or people that it shouldn't be. One of the big challenges that we have on the perception team is robustness, especially to new scenarios that we haven't seen before.
Unsurprisingly, one of the most powerful tools to help achieve this is machine learning.
You can do vision without AI. You can do things like object recognition. There are traditional algorithms for that, but since AlexNet came out, it beat every other traditional model on this large database called ImageNet. So there's really no better tool to use.
Neural networks are computing systems that process data in ways that mimic the human brain. And when using machine learning and neural networks, there is one resource valued above all else.
Data is the most important thing in AI. Without good data, we cannot build good AI. And so going and collecting more and more data as we go to more and more environments, we'll keep getting better and better at that kind of general base model.
If we gather a lot of training data for the machine learning model in a certain environment and we deploy in a different environment, that's going to really start to challenge our perception algorithms.
Currently, perception algorithms require lots of human intervention and maintenance, and they are mostly tailored to specific tasks. Engineers have to manually filter through training data to help teach the model what's what. But the world isn't predictable, and it isn't easily modeled. It's full of randomness and uncertainties, so general-purpose robots will need to be able to adapt on the fly.
We try to show the models as much as we can of variation that's even unrealistic so that it can generalize to a good point.
Instead of developing a perception algorithm to run once on one set of data, we want to be developing an algorithm that's robust to unseen scenarios. One thing that we're constantly thinking about is identifying those cases where the perception algorithm fails, filter that information back to the engineers, and then we can design different algorithmic solutions for that.
The goal is that someday robots will be able to do this themselves, using their onboard systems to detect failures and make corrections.
We have so much complexity, so many things that come into play, and we want Digit to be able to interact with all of those things and handle them dynamically, handle people in situations and totes in unknown locations, things like that, and be able to still do its job safely.